Well, hello. Now we are on the second half of Calculus 1. We are going backwards. So we're doing antidifferentiation and indefinite integrals, which means we're going to do definite integrals later. Okay. So the first thing we're going to do is look at what we know about going forwards, that taking the derivative, right? So let's remember and go through our practice. So number one, we have f of x equals x cubed. So that's a power rule, right? So when we take the derivative, we get 3x squared. Piece of cake, right? Now, number two, we have a different function. This is f of x equals x cubed minus 10. Okay, different function. Let's take the derivative. So f of prime of x equals, well, x cubed would be our power function, right? So 3x squared. And then we have minus 10. Well, what's the derivative of 10? It's a constant. So the derivative of any constant is 0. So we're done. But wait a second. That's the same. That's the same derivative. Different functions, same derivative. So what does that mean? Well, let's just check. In number three, we have f of x equals x cubed plus c. So c could be any constant. It doesn't have to be 10. It could be 1. It could be 500. It could be a million, right? So if we took the derivative of that, though, that x cubed is still 3x squared, and the derivative of any constant is 0. So in other words, right here, this x cubed plus c, and c can be any constant, we're talking about an infinite amount of functions, but yet their derivative is all the same derivative. So what does that mean in the long run? Well, that means that if we were to go backwards, so I know that going backwards, so what function gives me the derivative of 3x squared? Well, we know that's x cubed, not x squared, x cubed. But the truth is, we could be adding on any constant because that c there can be any number. So what you want to make sure that you are doing when you're doing indefinite integrals, in other words, there's no boundary, you're talking about any function, any place, you have to remember that a constant could be there at any time. And we don't know what that constant is at a particular moment. So when we do the integral, so this is the integral sign of 3x squared, okay, which is our power rule, but we have to go backwards. I'll explain that in a minute. You have to keep in mind that you have to always add on a c because there could be an extra constant there. We don't know what it is at this point. Okay, so let's break this down. The symbol of this is your integral symbol, okay? It tells you to integrate. So the directions don't have to say integrate this. If you see this symbol, it means you need to integrate, okay? The expression is called the integrand, okay? So like the 3x squared is the integrand, and dx indicates that you are integrating with respect to x, but does not affect the process. So it's just telling you what variable you're going with, okay? C is the constant of integration. And of course, when we're doing our integrals, our integration, and we have indefinite, so in other words, no boundaries, that will make sense later, you have to have a plus C, okay? So right now we're going to go some triggers. We're going to remind ourselves, but also remind ourselves how we go backwards, okay? So here is the idea, power rule. So when we went forward, when we took the derivative, we were putting the exponent in front of the coefficient there, right? Exponent in front, and subtracting 1 from that exponent, correct? Okay, so So when we go backwards, we have to go backwards on those steps. So remember, to differentiate, our last step was to subtract 1 from the exponent, right? So what we're doing is we're going to do that first. So for a power rule, we're going to go backwards. We're going to add 1 to n, okay? And then instead of multiplying by the exponent, since we're going backwards, we're dividing by that exponent, okay? Constant rule. Remember that if there's any constant, so if we're taking the integral of any constant, we're going backwards, that means there is an x to the first now to it, right? Kind of like your power rule again. Scalar multiplication, well, just like we did with differentiation, we can ignore that coefficient and just multiply it in. Same thing with integrals. So right here in the example, k is our coefficient. So what we could do is kind of ignore it and put it out front and just take the integral of our function and then multiply it at the end, okay? Sum rule, again, if you see two functions that are added or subtracted together, you can actually simplify those or separate those. And sometimes you really want to do that because you're using different rules, right? You could be doing a power rule and then an exponent or exponential rule, okay? So now the good thing is you can always check your work by taking the derivative of what you found for an answer and see if that comes to your question. So the integral of e to the x is still e to the x, but don't forget the plus c, right? The integral of a to the x, so this is exponential. So remember, it's itself, but usually when we go forward, right, it's itself, and we multiply by ln of the base. So since we're going backwards, we're going to divide by ln of the base. So you got to change your frame of mind of going forwards or backwards, okay? Now, trig rules. This is where it gets tricky. We are going backwards. So really in the long run, and I'm going to go through this little by little, and eventually you're going to memorize it and it just comes out. So we're asking ourselves, what function, when you take the derivative, you get cosine? So what trig function do you take the derivative of and get cosine? Well, hopefully you were saying right now, sine x. Now don't forget, this is indefinite, so I have to have a plus c. Okay, what trig function, when you take the derivative, gives us sine? Now, this is the tricky one. Okay, well, I know cosine gives us sine, but cosine gives us a negative sign. So since I want this to be positive, it means I need this cosine to be negative. And then, of course, plus c. Okay, this is why I like thinking this process for starters until you memorize them. The integral of secant squared. What trig function, when you take the derivative, gives you sine squared? Well, hopefully you're telling me tangent. What trig function, when you take the derivative, gives us cosecant? Hopefully you say cotangent, and then you realize, wait a second. Oh gosh, sorry guys. Give me a second. I've got to go turn the light back on. All right, so let me go back to what I was saying. So cosecant squared, you should think of cotangent. That's awesome. But then you realize, wait a second, I'm talking about cotangent. When I take the derivative of cotangent, it's a negative. But I'm talking about a positive here. So that means I also have to add a negative on there. Okay. Which trig function, when taking the derivative, gives me secant tangent? Hopefully you're saying secant. If you were not saying these things, that means you need to be focusing on your rules for trig. Okay. And then cosecant, cotangent, of course, that's going to be cosecant. But remember, I hesitate and say, wait a second, that should be negative. And this is positive, so a negative times a negative is a positive, right? So that needs to be negative right there. Okay. All right, so just a side note down here, the most common errors made with trig functions are sign errors. The sample diagram at the right, reminisce the unit circle, may aid in remembering rules for those two trig functions to use far more than any other trig functions, rotating clockwise for derivatives or rotating counterclockwise for antiderivatives. This also means, guys, when you plug in, you need to just make sure you're going in that right direction, okay? All right, let's see. Now we're going to do some practice. Okay, now we're only going to deal with these rules that I just went over. Okay, so as you can see, just like with derivatives, I want you to identify the rule before you do any work. Okay, so if I look at number 4, I'm taking the integral of x cubed, which means this is a power rule. Now remember though, I'm going backwards. So I have to, instead of multiplying by the exponent and then subtracting 1, I'm going to go backwards and do the opposite, right? So I'm going to add 1 to the exponent, so x to the 4th, right? And I'm going to divide by that exponent. Don't forget the plus c, okay? Add to the exponent, divide by that exponent. Number 5, integral of 2 dx. This is a constant rule, which means all I have to do, because it's in terms of x, is add on an x to it. So this is 2x plus c. And again, you guys can take the derivative and make sure you come up with your original question. Okay, this one, again, I'm going to do this in long terms so that way you can see how you can separate, but in this one, I understand if you don't. So this is saying, guys, integral of t to the 4th dt plus integral of 2 dt. And again, I'm just separating that now so you can see the two rules, right? So this is the power rule and this is the constant rule. Remember, my power rule is I add 1 on to the exponent and I divide by that exponent. Okay? And then there's the constant. Constant means I just hook on that t. But don't forget, this is an indefinite integral, so I have to have a plus c. Okay, so this one I separated. This one I'm not going to separate. Okay, guys. This one I'm just going to go through because it's power rule, constant rule. Okay, so again, add. So I have 2. That stays there, right? That's like your scalar where we just keep it there for now. And then I have y. I'm going to add 1 onto the exponent and divide by that exponent. So that's the first term. Second term, I'll keep the 4 there. Add 1 to the exponent, so now the exponent is 2, and I need to divide by that exponent. And as you can see, I can still simplify this to 2y squared. Now, depending what I have to do in the long run, yes, I should simplify it. But if all I had to do is take the derivative, if all I had to do is take the integral and stop right there, I would keep it, right? And then we have a constant of 1. So I'm just going to hook on that y. Don't forget that constant of c. Okay. Now we're starting to get into the more complicated ones. And remember with derivatives, I've always said, like, make sure you simplify it before you figure out what rule you're using. Okay. Now, number 8, you guys should recognize that this is something over a monomial. And when we have monomials, meaning one term, we're going to separate them, okay? Now, I'm not taking the integral yet, so my integral symbol still needs to be there. This is going to be the square root of x over x squared plus 1 over x squared dx. I'm still going to simplify. I am going to reduce this. So in other words, the square root is 1/2, right? And when we divide with exponents, we subtract them, right? So 1/2 minus 2 is a -3/2, right? So this is going to be x to the -3/2. And I'm going to bring this x squared up by making it a -2 dx. Okay? I'm going to keep going because I still need to take the integrals. I'm going to do number 9 in a different place. Okay? Remember, power rule, power rule. So, I add 1 to the exponent. If I add 1 to -3/2, I get -3/2, or -1/2, sorry. And then I divide by that exponent, right? So I'm dividing by -1/2. Then I'm going to add, there's another power rule, right? I'm going to add 1 to the exponent, so -2 plus 1 is -1, and divide by that negative exponent. I'm also going to simplify this, guys, because you need to get in that habit. Dividing by a -1/2 is the same thing as multiplying by -2. Right? And so this would be -x to the -1 plus c. If we had to put that back in fraction form, we could. Okay, now that I used all that space, I still need to do number 9. So I'm actually going to do number 9 up here. So let me rewrite this. This is the integral of -3 sine x dx. Okay, I'm going to do it in the scalar multiplication style so you guys can see. This is the coefficient out front here, so we're going to just bring this out here so it doesn't distract me. So as you can see, what I'm really doing is taking -3 and multiplying it. I don't need that symbol there, by the way. Multiplying by the integral of sine, right? Well, the integral of sine, okay, is negative cosine. Don't forget plus c. Now, if you are not doing the negative times negative in your head, make sure that you have parentheses around here so it doesn't look like -3 minus cosine. So, but a negative times a negative is a positive 3 cosine x plus c, and you just did number 9. Okay, number 10. I'm going to separate this, of course, because I want you to see the two different rules, even though they're both exponential. Okay, so we're going to do the integral of e to the x dx minus the integral of 2 to the x dx. Okay, if you look back at your rules, we have the integral of e to the x is itself minus, okay, the integral of an exponential is itself. But since we're taking an integral, we're not multiplying, we are dividing by ln of that base and plus c. Now, you might be wondering why, well, why is it, do I not do a plus c here and a plus c here? Well, a plus c there and a plus c there is 2c, which is just another constant. So all you need to do is have that one there. Okay. All right, I'm going to rewrite 11. I'm not going to separate them, but I'm definitely going to rewrite that cube root, okay? So we take the integral. This is 5t to the 2/3 plus cosine t minus 1. Now, why do they have parentheses here? They have parentheses here because they want to show you that that dt goes to all of them, not just one. Okay. The reason why they didn't have to do it here is because a fraction times anything is just multiplying straight across. But this, so as you can see, it did in number 7 too. They have the parentheses with that dt, dy, dx, so it goes through each term. Okay. Power rule, trig rule, constant rule. All right, so keep the scalar multiplication there, t. Now, what are we doing in the exponent with integrals? We're adding 1, so that would be 5/3. Now, I'm going to do this quickly. Instead of saying, hey, now I divide by that exponent, so I'm dividing by 5/3. What's the same thing as dividing by 5/3? Multiplying by 3/5. Okay, so I'm just doing that quickly so I can simplify more, which means these two fives cancel each other out. 5 over 5 is 1. Okay, now plus, what is the integral of cosine? The integral of cosine, what do you take the derivative to get to cosine? Well, that's sine t. And then we have our constant. So of course I'm going to hook on that t. And don't forget that constant of c. Okay. All right. Number 12. I want to rewrite this. Now, even though we're dividing by 4 and it's a monomial, since it's a constant, I'm actually going to rewrite this as a scalar multiplication. So dividing by 4 is the same thing as multiplying by 1/4. Okay. So now, knowing it's a scalar multiplication, I can keep that up front. And what's the integral of secant y tangent y? Well, that would be secant y. Yeah, I forgot the c. Very good. Okay. All right. So put plus c when you integrate, but never when you differentiate, right? When you go forward, you're not doing the plus c. When you're taking the integral, you're doing plus c with no boundaries. Okay, so what happens? Because in the long run, yes, when you take the integral, you're going to have plus c. But then sometimes they give you some positioning coordinates, and you're actually able to solve for that c and find the true function. Okay, so that's what we're going to do in example 13 here. We have f prime is cosecant squared x, and f of 5 pi over 4 equals 3. Okay, so as you can see here, what the first thing we're doing, because we have the derivative, but we need the function, that shows you you're going backwards. So what we're going to do is take the integral of cosecant squared x dx. Okay, so what is the integral of cosecant? Well, the integral of cosecant is negative cotangent. Again, sometimes you'll have to use your rules until you memorize them. But don't forget, when we do this, we have a plus c, just like we did in questions 4 through 12. But now we're going to use this information that was given to us extra to actually solve for c. So remember that this is the x value. This is the y value. So what we're going to do now is set this up and say 3 equals negative cotangent of 5 pi over 4 plus c. Okay, now of course you guys got to do your unit circle. Well, cotangent of 5 pi over 4 is positive 1. So 3 equals negative, and then cotangent 5 pi over 4 again is 1 plus c. Now we're going to solve. How do you get c by itself? We get 4 equals c. Now again, it was asking us to find the function. So even though I just found c right now, I'm not done. I still need to express that now the true function to make all this satisfy what we need is negative cotangent x. Now instead of plus c, we just solved for it. It's going to be plus 4. Okay. less 4. Awesome. Okay, let's see what notes they're giving us here. If we know the acceleration equation of the object, and if we are given initial conditions, so in other words, when t is 0, velocity is this, or when t is 0, we're in position this, integration allows us to find the actual velocity and position equations for the object because we're solving for c, okay? So we are given right here that a of t is 4t minus 3, and we are given initial conditions, okay? Or a condition, okay? It's not definitely like t is 0, right? The starting. So here, find the velocity. So in other words, we are going acceleration now to velocity, which means we are going backwards. We're going backwards here. So what we're going to do is we're going to take the integral of 4t minus 3 dt. We're going to solve for that first, okay? So power rule, constant rule. So let's see. Keep the 4 there. T, add 1 to the exponent, so squared, divided by 2. And then our constant is 3. And then we have to hook on that t. Don't forget the plus c. Okay? Now, of course, you can reduce this to 2t squared minus 3t plus c. Okay? But since we're finding the velocity equation, we want the exact one, we have to use the initial condition that they gave us, or the condition they gave us. So when x is 1, y is 6. So I'm going to plug that in. So 2 times 1 squared minus 3 times 1 plus c equals 6. And then I'm going to solve. Okay, when we solve for this, we get that c equals 7. Okay. 2 minus 3 is -1. Add 1 to the other side, you get 7. Okay, so now when we find the position, because the position is going backwards of the velocity, we are taking the integral of this 2t squared minus 3t plus 7. Okay, so power rule, constant rule. Okay, so I'm going to do this down here. So I have 2 up front. I'm going to add 1 to the exponent, divide by that new exponent. Okay, minus 3t, add 1 to the exponent, so that's squared, divide by that exponent, plus the constant. Well, that means we have to take the integral of the constant, so we hook on the variable, and then we have a plus c. Now, sometimes AP tests will get picky and sometimes they're not. Here's a problem right now. I just identified in A that this was C. But now I'm putting another C here. And it gets confusing because you're like, wait, which one's which? So what we do sometimes in calculus, especially if we're dealing with multiple constants that react to different functions, we label it in a sense to remind ourselves. So what I'm going to do, go back here and put this as C subset 1. Okay? Because now when I'm doing it again, I'm going to do that. This is C subset 2. It's a different C value. So when I plug back in, I don't get confused what C I'm looking at. Okay. Now, this one tells me that in the position, when x is 2, y is 5. So I'm going to do that now. So 2 times 2 cubed all over 3 minus 3 times 2 squared all over 2 plus 7 times 2 plus c subset 2 equals 5. And then we're going to solve for c subset 2 here, okay? Now, I'm just going to do it for you. really quickly and give you the answer. But don't forget, if you can use the calculator, use it. If you can't, make sure you break down, making sure that you're adding and subtracting fractions correctly, okay? So this will end up being that C subset 2 equals negative 25 over 3, okay? Try that without your calculator, see how quickly you get there. Now remember, my question was, what is S of t? So if you want to even indicate this more, keep in mind that this is V of t. So V of t equals the 2t squared minus 3t plus 7. That's why we took the integral of that. So S of t equals 2/3 t cubed minus 3/2 t squared plus 7t, and then it's going to be a minus 25/3. Now again, why is it appropriate to use the C subset 1 and C subset 2? Well, remember, when I have to rewrite this and I'm filling out the C, I know exactly I'm talking about this C, not this C. So it just helps you identify which one you're doing. Okay, just 2 more problems, I think. All right. Now we're really going to go into not just position, velocity, acceleration, but we're going to see how physics really allows us to maybe get some answers faster. Because you saw how long it took for us to do the velocity and the position. Well, here's the idea. If what's given to us is the initial, meaning subset 0, the words I was using before, right? You have to keep in mind that gravity, right? If you guys are in physics now, you realize, hey, what do you know? My position is usually negative 16t squared plus the initial velocity of t plus the position, initial position. I'm going to solve this the long way. But at any time that you are given the initial, you can go straight to here or here. That's up to you. I'm going to do it the long way, as if I've never seen physics stuff before, if only I'm doing calculus. And I know that to go backwards, I'm going acceleration, velocity, and position, okay? So first of all, what I'm going to do to find the velocity is take the integral of the acceleration, which is 32 dt, because we're talking about t, okay? Okay, if we take an integral of a constant, we end up getting just the negative 32 and then hook on that variable. But don't forget, this is no boundary, so this is plus c. Okay. Now, the initial velocity, this means that when I plug in 0 for t, I should get V subset 0 should equal negative 32 times 0 plus C. Now I'm going to do this again, so I'm going to put C subset 1, which means C subset 1 is V subset 0. So let me rewrite that. So that means V of t equals negative 32t plus initial velocity. And what do you know? That's how we got the equation there. Let's do the same thing with the position. So I'm going to take the integral of the velocity. So we have the integral of negative 32t plus v subset 0. Now don't forget, this is a constant. This is a number, okay? So, and this is of dt. All right, so we have power and constant. So what we have right now, negative 32t, add 1 to the exponent, divide by that exponent, plus, this is a constant, so we have that, and we hook on a t, And then don't forget the plus c, but of course I'm going to label this as subset 2 since we already used this c over here. We know that when t is 0, we should get the initial position. So when we do negative 32 divided by 2 is negative 16. T is 0 because we're dealing with initial squared plus v subset 0 times 0 plus c subset 2. Now, of course, what does that mean? When you solve that, 0 plus 0 plus c subset 2 is c subset 2. So initial position equals c subset 2. And that's where you get this equation here. So the good thing about doing this right now, guys, like I said, if you are talking about the acceleration being negative 32 feet per second squared, and you are given the initial velocity and initial position, you can go straight to this equation. Okay? But you can also do it the long way. No big deal. All right, that's done with the first section of integration. So practice. Try to memorize those rules, okay?